Hey physics fam, today we're looking at free fall problems that plug into our Fab 5 kinematic equations. So looking at number 1, an astronaut drops a feather from 1.2 meters above the ground. So 1.2 meters above the ground, to me, means that that object is going to fall 1.2 meters, which means my displacement is going to be negative 1.2. Now, the acceleration of gravity on the moon is 1.62. So let's address that. 1.62 meters per second squared. But remember, it's acceleration of gravity, so it's always pulling down. So that also has a negative number. How long does it take the feather to hit the surface? So looks like a question I'm going to have is how long? So I'm looking for time. So if I'm doing my guess method, my unknown is t. My g, or given, is displacement, acceleration, and something else. Let's see. Oh, if I'm going to drop it out of my hand and onto the ground, I can assume my initial velocity is 0 meters per second. Great. Now that I have that, I got to figure out which equation I'm going to use. Well, if we look at my given and unknowns, I'm using everything or solving for everything except for velocity final. So I'm going to look at my equation that doesn't have velocity final in it, and that ends up being the equation delta x equals velocity initial times time plus 1/2 acceleration times squared. All right, now that I have that, let me start plugging that in, substitute s to get my answer. All right, so let's rock that. Let me get a new color. I'm going to use blue for this. So displacement delta x is negative 1.2 is equal to velocity initial, which is 0, times my time, which I don't have. I'm going to solve for that. And then I'm going to do 1/2 times the acceleration, negative 1.62, times my time again, which I don't have. Here's the beautiful part. 0 and time cancel out. So I'm left with 1.2 equals 1/2 times negative 1.62 times time. To solve for that, I need to get t all by itself. So I'm going to need to divide over this 1/2 times negative 1.62 to both sides. All right? 1/2 times negative 1.62. You can do that all in your calculator if you'd like. But what I end up getting is time is going to be equal to about 1.22 seconds in that example. Awesome. Perfect on that. We used our equation. We figured out. Please note, though, that we did have to make an assumption. We had to assume that the initial velocity was 0 because we were dropping it out of our hands. So keep that in mind when we're doing these problems with free fall. Anything that's falling through the air, we can assume the acceleration of gravity of that place or planet. A lot of times that's Earth for us, but in this case it was the moon. And then also we could sometimes assume things like initial velocity is 0 if we were going to drop an object. We know it starts from rest. All right, let's carry on and move to the next one. Looking at number 2, I'm going to give myself a little bit more room. It says a rock is thrown vertically upward with a velocity of 2 meters per second from the edge of a bridge, 42 meters above the river. Wow, okay. So if I'm looking at like a bridge, and here's me, I'm about to throw a rock up in the air, and then it's going to eventually fall back down. Now we know a couple things. We know that that bridge is 42 meters high, okay? We also know that the initial velocity thrown up for that object is 2.0 meters per second. Perfect. We want to know how long the rock stays in the air, so it looks like I'm trying to figure out the time it's in the air. All right, well, let's think about some of the things we're given here. First of all, I'm given that my initial velocity is 2.0 meters per second. I'm also thinking about my displacement. If that rock goes up and down, the total displacement will be 42, and technically negative 42 meters. Because we remember, all we care about for displacement is the starting position and ending position, which really is just the 42 meters. Awesome. We also know that this thing is falling through the air, so the acceleration of gravity is affecting it. So we have that information. And of course, we already know we're looking for time. So because of that, we have an equation that has everything except for final velocity. So we need to set up for final velocity. I'm sorry, not for final velocity. We need the equation without final velocity. So I'm going to do my displacement equals velocity initial times time plus 1/2 acceleration times squared. All right, let's start plugging in for that. When we plug in for that, we're going to see something that we aren't going to be too particularly excited about, but let me put it in together here. So velocity initial is 2.0, time I don't know, plus 1/2 negative 9.8 t squared. We start setting this up and cleaning it up a little bit. What you're going to notice is this is actually going to be set up like a quadratic style equation. And if you've ever dealt with quadratics before, remember you set it equal to 0. So I'm going to put 42 to the other side. And when I do that, I end up getting 0 equals 2t plus negative 4.9 t squared plus 42. Now that is a quadratic style equation. We can plug that in, and you can do that a couple ways, all right? This isn't something I normally give you on a test or quiz. It'd take too long. But if you have a graphing calculator, you can plug it in to quadratic solver. You can also just Google quadratic equation solver and plug in for it as well. But when you plug in for that, you end up getting the time t equal to about 3.13 seconds. All right, so hopefully that helps you out. And again, that is a little bit more of algebra than we're used to doing in here. So again, don't panic too much about it for a test, but being able to plug in, see that, and identify that is great practice. And also reading all this information and figuring out what equation to use was also great practice. But let's move on. Let's finish up with question number 3. During a baseball game, a batter hits a pop-up. So we're gonna have a ball that's going to hit a pop-up. It's gonna go up and down. The ball remains in the air for 6 seconds. So that total time it goes up and down is 6 seconds. We want to know how high does it rise, meaning what displacement, delta x, does that ball go up in the air, so its highest point. All right, we don't have much information, but I think we can start making assumptions to figure this out. So first of all, given is time. Here's the problem though. I'm trying to find the very highest point of the ball, how high the ball went. That was technically halfway through the trajectory. So I'm going to divide that time in half so that I know I'm at the time where the ball's really at the highest point, which would be 3 seconds, half of 6. I also know this is under the influence of gravity. So we know it's negative 9.8 meters per second squared, that gravity's working out the whole time. And also it says in this problem, hint, what is the velocity at the top of the path? Right there, I'm going to assume that final velocity, just at that very highest point the ball hits, is at 0. Why? Because we know at the highest point some object is in the air, eventually it stops for a very split second and then starts coming back down. So it looks like I have everything I'm looking for. Now I'm going to start finding my equation and substituting in. So let's figure that out and also clean up my writing here. So here comes the equation. I'm using everything but initial velocity. So that means the equation I'm going to use is going to be displacement is equal to final velocity times time minus 1/2 acceleration times time squared. All right. Now that I have that, let me start plugging in. I don't have anything for delta x. By the way, this is S for substitute. But I do have final velocity is 0. Time is 3 seconds. This negative 1/2, I'm going to change to add plus a negative 1/2. That just makes me feel better with my math. Acceleration of gravity is negative 9.8, and my time is 3 seconds squared. If we look at this, a couple nice things happen. 0 times 3 is 0, so that cancels out. I'm left with just displacement. And if I did 1/2 times negative 9.8 times 9, because 3 squared is 9, I end up getting an answer of about positive 44.1 meters, which means that this ball went up about 44.1 meters when it was at its highest point. Game, set, and match. Problem solved. Awesome. So there you have it. If we read through it, take all the information we're given and try to make the best assumptions, we have a better chance of solving it. So, way to go. Keep trying these out. Keep working through it. And remember, if you don't feel like you have enough information, then maybe we just have to work on trying to get just a little more assumptions in there to solve it. But be well.